Hello everyone, and welcome back to another installment of our workshop series. In this episode, we're going to be going over the ins and outs of string manipulation in Java. In this first part to this multi-part workshop, we will be covering an overview as well as the basics of strings. But as we move on further into more parts, we'll be looking at more complicated topics and even looking at specific algorithms and specific questions. So why do we care? Why look at string manipulation? So not only is string manipulation a topic that is very useful in many aspects of software development, it is also a very popular topic for interview questions by many companies, including the top ones like Amazon and Facebook. So string manipulation problems often require novel approaches and creative strategies that are a good test of your problem-solving capabilities. This workshop is aimed to help you guys get a good grasp of conventions and an understanding of string manipulation, and we'll be focusing on strings and how they are represented in Java specifically, and we will be discussing Java-specific syntax. Another note is that due to the topic in question, this workshop will be more conceptual than the workshops we've done previously, so just keep that in mind. So without further ado, let's go ahead and get started. Okay, so what exactly are strings? In all programming languages, strings are the data type used for storing and representing text. In Java, strings are an object, which means they are a non-primitive data type and are backed by a string class. And this means that all strings in Java are instances of this string class. Being a class means that strings get their own fields and methods specific to them, which we will go over a few in this workshop. For example, there is the length method. So strings can be declared with double quotes as a string literal, as so, or with the string class's constructor using the new keyword. One very important thing to know when dealing with strings is the distinction between strings and characters. Characters are a primitive data type, meaning that they are the most purest and most rudimentary form of data. Other examples of primitive data types include integers, booleans, floats, and they are not backed by a class. Whereas strings are not primitive data types and are backed by class. So characters appear surrounded by single quotes versus the double quotes for strings. Here you can see an example of the letter A as a character C and as a string S. And note that C does not equal S. These two variables are not equal, even though they both represent the letter A. Another thing to note is that all strings in Java are represented as an array of characters. So declaring a string as so, string S equals ABC, is also equivalent to creating an array of characters A, B, C, and then using the string class as constructor and creating a new string using the array of characters. Because strings really are an array of characters, accesses made to specific indexes of a string are in constant time. Using the char at or character at method of a string returns the character at that index of the string. And because Java is zero indexed, the index 1 of a string that is ABC is the character B. Another crucial property of strings is that they are immutable, or that the values of strings cannot be changed once they are declared. However, a string variable can be reassigned. In this example, using the concat function to concatenate or append string DEF to ABC, more on concatenation later, and this does not actually mutate the value of S. So after this code is executed, if we check the value of S, we still get ABC. However, if we do this, and we reassign what the value of S points to the resulting value of the function s.concat_def, if we check the value of S after that code, we get S being ABCDEF, which is the value of what we intend to do. And this is because what this concat function is really doing is, instead of mutating S, it returns and creates a new string with the value of s and df combined. And because we reassign the value of s to that result, s is now a, b, c, d, e, f. So strings in Java have a length property of the number of characters it has. And this can be obtained using the .length method. So if we have a string s, which is abc like before, we can call s.length and we would get returned the value 3. And this is because abc has 3 characters. So for getting the last character of a string, we can use the char@at function from the previous slide and then call that on the last index of the string, which is always going to be that string.length minus 1. And this is because length counts from 1, so we count ABC would be 1, 2, 3, length is 3, but the index counts from 0. So the last index starts from 0 and it'll be 0, 1, 2. So the length, or the last index will always be 1 less than the length of the string. For comparison, there are 2 different ways of comparing strings. One is the dot equals and one is the double equals sign. The dot equals sign, or dot equals function, I would say, compares the actual values of the string. So it compares the content of the string, versus the double equals checks if the 2 objects, or any 2 objects, point to the same memory location. So for this block of code, if we declare string s1 to be abc and declare string 2 to be also abc, if we do s1 dot equals s2, that expression will evaluate to true. This is because the contents of the string are equal. They are both abc. However, if we evaluate this expression s1 equals equals s2, this evaluates to false. And this is because these 2 strings are 2 different variables. They are pointing to 2 different things, even though their contents are the same. So just keep that in mind when you are using comparisons for strings. And just know that if you want to compare the actual content of the string, it is recommended to use the dot equals function. Alright, so as we saw previously, a string of the letter A and a character of the letter A are not equal in value because they are different data types. Sometimes this can be an issue, as we may want to compare 2 objects for their values as strings and have sort of a common ground for comparison. And sometimes we may want the opposite. We may want to, for example, do integer math on numbers that happen to be in string format. So first, let's go over how we can resolve a different data type to a string, or using strings as the common ground for comparison. So there are 2 options here. We can use the string.valueOf method for primitive types, or we can use the toString method that all objects inherit for objects. And this is for like data structures represented with classes. So going back to our example of resolving the difference of a character A and a string of A. So let's say we have a string s equals the letter A, and this is actually the same as declaring string s equals string dot value of the character A. And note that the character A is in single quotes, so it's a character. So we can sort of cast the character into a string using the value of method. And this is because we're using value of because characters are primitive types. Another option that you can do is sort of displaying an array as a string. And this is using the toString method. So if we declare an integer array of 1, 2, and 3, we can create a string out of that integer array using the toString method. And then that string will become sort of a textual representation of that array, 1, 2, and 3. And this can be helpful for visualizing things. Moving on to the other instance, sometimes we may want to get the value of what a string is as a different data type. Let's say we want to do some math on this 123 or 123, but we are given 123 as a string for whatever reason. We want the numerical value of the string as an integer. To solve this issue, we also have two options. So we can use the integer.valueOf method. This converts the string into an integer. And note that integer with a capital I is a class and not the primitive type int. But this really doesn't matter, as Java automatically casts between int and integer, so that we can declare int I with lowercase int equals integer dot value of the string 1, and I evaluates to 1, and even though the right side of the equal sign here, integer dot value of 1, is a class integer, we can still use int I and it will be just fine. So the other option is using integer.parseInt, and this pretty much does the exact same thing. So if we do int I equals integer.parseInt with the string 1, I also evaluates to 1. And the situation where this may come up very frequently is when using the buffered reader and the readLine method, which reads an entire line from a certain file descriptor as a string, regardless of what the contents are. So if you want the actual number values from a file that you're reading in, we can do what we did here and then get the actual number values from those strings. Our next topic is string concatenation, which is a fundamental part of string manipulation. String concatenation is the act of combining or attaching strings, forming a new string from the combination of two or more strings. You've seen this in action already. In the previous slides, we used the concat function for this, but in my opinion, a much more easy method is to use the plus operator to concatenate. So in this block of code, we first create a string equal to ABC, and then we do s equals s plus the string def. And now, if we try to evaluate this expression s dot equals the string ABC def, this should evaluate to true, because the value of s should now be s, or should be ABC def, now that we've reassigned s to the new concatenation. And note that the equals method is comparing the value of the string. So we're comparing the value of s and that string literal that we declared there. So notice that the plus operator is the same operator used for numerical addition. This actually results in some pretty neat and funky things we can do. One thing is there's automatic type conversion when adding, for example, an integer and a string. So let's say we declare a string equal to ABC, the string ABC plus the integer 1, 2, 3. S evaluates to the string ABC 1, 2, 3. What happens here is that once the Java compiler sees that we're using the plus operator on a string, whatever comes after that, for example, like an integer here, that gets changed to a string, and then the string sort of overrides whatever that value was there, or that data type was there, and turns it into a string. So because of this, we can pretty much easily convert integers to strings using the plus operator and just adding an empty string. So because the string sort of overrides the integer data type, if we declare string s equal to the integer 1, 2, 3 plus an empty string, s is really just now the string 1, 2, 3. And we don't have to bother with the functions that we've gone through before. And another thing is that expressions with the plus operator are evaluated from left to right, which means that let's have this expression here with string s equals 10 plus 10 plus abc, and first the compiler will evaluate 10 plus 10 as if it was an integer addition, and that just results in 20. But then it sees that we're adding ABC, or trying to concatenate the string ABC, and then it converts 20 to a string and then concatenates both of those two. And then this string s now evaluates to 20 ABC. So just keep that in mind whenever you're doing some crazy stuff like this. But yeah, it may not come up too often, but just keep that in mind. As you know, when creating a string, the entire sequence that you want to be as a string must be enclosed in double quotes. But what if we want to have double quotes within that string? So double quotes signify to the Java compiler the start and ends of strings. So let's say we wanted to have this string here, Bob said hello, in double quotes, or with hello in double quotes. This would result in a syntax error. And this is because when the Java compiler goes through this expression, it encounters the first double quotation mark right before the hello. And then this tells Java that's the end of the string. And then everything after that would be invalid and result in a syntax error. So luckily there's a solution for this, and it's called character escaping. So the backslash operator, or the symbol, is a special symbol exactly for this purpose. Using the backslash symbol in a string escapes the very next character that appears in it, and it tells Java to interpret the next character as a string, regardless of what it is and what function it may serve. So for this case, if we use backslash and then followed by double quotes, this allows us to display a double quote mark in a string. So if we now fix the expression that we had before, and now declare string s as Bob said backslash quotation mark hello, and then backslash quotation mark again, and then closing off the string, this gives us our intended result. And one thing you can even do is escape the escape character with backslash backslash and allow us to display the backslash, because otherwise the backslash character doesn't really appear as a string if you just use it on its own. So what we did just previously using backslash and a quotation mark is called a control sequence. There are many different control sequences in Java for other special functionality within a string, but here are some of the most commonly used control sequences. As you can see, /t creates a tab, which creates a certain amount of white space. Backslash n creates an entire new line. Backslash b is backspace, which isn't really used too commonly, but it deletes a single character within that string. Backslash single quote allows us to display a single quote, and these two you've already seen. Backslash double quotes allows us to display a double quote, and backslash allows us to display a backslash. Now let's go over a few useful functions that are very helpful when doing string problems. This is not an exhaustive list. There are many other functions other than these three that are very helpful and that you may also use, but these three I chose because they have been the most common for me and have been very useful for me personally when I've been doing string problems and doing the problems that I've encountered so far. So the first one is the to-char array function. And this function returns a character array of the characters of the string that you call it on. So if we have a string s equals a, b, c, d, e, f, and we do s.toChar array, this returns a char star that can be iterated over with for each loop, for example. And this removes the need to have to make a for loop with a counter and then call the string .toChar at that certain index or that certain counter, and then do that iteratively with a counter instead of just going through each character of this array with a for each loop, which makes it a lot easier whenever you're doing problems that may require you to examine characters one by one in order. So the next function is the index of function, and this is a very, very powerful method that returns the first index where the input string occurs entirely within the string that is calling the method. So if the input string does not appear at all within the calling string, instead of returning the index where the input string occurs, or where it starts, I would say, it returns -1, which means it doesn't exist at all within that string. So using the string S as we have declared before with A, B, C, D, E, F, if we do s.index of the string BC, it returns the first index where BC occurs, or BC starts to occur. So that should be 1, right? Because A, B, C, D, E, F, or BC appears is the very second letter, which is going to be index 1. But if we were to, let's say, call s.index of a string of like Z, for example, Z does not appear at all within A, B, C, D, E, F, and you'll return -1. So the last function in this list is the substring function, and this is a very, very important function, or very important method, I should say. And there's two ways of doing this method here. So either you can call substring with only one argument, which is just one integer as the begin index, or you can call it with two integers, the begin index and the end index. And what the substring method does is it sort of splices a string. So you can think of a string, and you can think of like a knife. And what substring does is it cuts that string up and returns a new string that is a sort of spliced or cut version of the string with like a certain section completely removed. So the first method of doing this is using just the begin index. And this creates a new string starting from and including the begin index of the original string to the end of the original string. So you can call this substring function to basically just cut off everything up until, but not including that index, and return everything after that index as a new string. So if we call s.substring with an index of 3 on the same string we declared above with s, now I should return DEF, because we return everything in this S string, including the third index and all the way to the end. So the third index is D, because we count 0, 1, 2, 3, which is A, B, C, D. We include D, and then we include everything after that. And this is the string DEF. The other way is if we give both begin and end index, we create a new string starting from and including the begin index, like we did for the other method, but we now go only up to the end index specified and not the end of the string. And the most important part of this is that the end index is non-inclusive and the begin index is inclusive. So if we call s.substring with 2 and 5, this returns CDE, because this returns the string S starting from and including the second index, which is C, 0, 1, 2, which is A, B, C, up until the fifth index. And the fifth index is 0, 1, 2, 3, 4, 5, which is F. But we do not include F. So we have everything from C, D, and E, and not including F, and s.substring 2, 5 returns CDE. Lastly, let's look at some useful tips and tricks that are helpful both when dealing with string problems, but also just when working with strings in general. So the first tip is strings are really a good way to visualize more complex objects or classes that you may create yourself that don't really have a built-in or textual representation. For example, this could be like binary trees or BSTs that you may create yourself. We've seen this before when examining the toString method, but it is really recommended to, when creating these new classes, to override the toString method that all objects inherit and create one specific to that object. So going back to the example of the binary tree, it may be helpful to write a toString method and override the toString method for like a node, and then printing this node will help you print out the entire tree, and thus it'll help you visualize the tree whenever you go to like system.out.print that object. You can easily see in the command line what that tree is, and that can just be really helpful for debugging as well. So the next useful tip is that string concatenation is a way to create unique keys from 2 or more values. So one example for this is, let's say we want to map pairs of numbers, for example, like dealing with coordinates, as a key to some arbitrary value. So let's say we want the pair 2, 4 mapped to some value, and the pair 4, 5 mapped to another value. The values don't really matter here, but all that matters is that we can actually use strings as a key, instead of dealing with something like tuples. Going through the hassle of that and creating like a new class for this maybe, but we can just do string key1 equals 2 plus any delimiter, let's say a hyphen in this case, plus 4, do the same with key 2, and now we have a string 2 hyphen 4 equals, or is mapped to some value, and string 4, 5 is mapped to the other value. And now you can easily check for these keys as they are represented now by one entity, and you can check for equality, check for existence in the hash map. And it's really easy now because we don't really have to deal with having another data type for this, another data type that's key. But it is important to have any delimiter that's not really going to appear in your keys as a delimiter, because we want to separate or have some separation between the different values, or the different distinct values for your keys. Just so, let's say we want to obtain unique keys later, we can split on a delimiter later. And it also helps because not having a delimiter might create some problems when having like a number like 2, 4 that could be mixed up with like 24, for example. So yeah, those are some useful tips and tricks. In the next installment of the string manipulation tutorial, we're going to go in depth into more practical uses of more of this useful functions section that we went over, and more string functions as well. We're also going to take a look at a few string problems as well, and examine those functions, those useful functions in practice within those string problems. And then we'll also go over some important algorithms or approaches to solving these string manipulation problems. So that's it for this episode. I hope you enjoyed, and I hope you tune in to the next installment of this workshop series.